everyone, welcome back to another lecture. In this lecture, we're going to be going over external libraries and the pen tool in Scratch 3.0. So without any further ado, I'm going to go ahead and go to New Project in the top right of the My Stuff folder as we have been doing. So it's not going to be so much of a demo, although we'll do a little bit of a project. It's not going to be so much as a project, this will be a demo, because it's something we need to know in order to progress further in the course, ideally, but it's just something that's not exactly something that we're going to make a project over, or a more advanced project over. It's just going to be more of a demonstration project. So I'm going to go ahead and go into the bottom left here in case you didn't see what I clicked. It's in the bottom left of the screen here. If you hover over it, it says add extension, at least in the online editor for Chrome I'm using. So if we click on that, we'll actually see, I know I haven't gotten over this yet, but the header up here will say choose an extension. And what it'll say is there's 9 extensions here, so these are actually called external libraries. The software development world, that's what we call them. Scratch just calls them extensions, but really that's what it is. And external libraries, or extensions in this case, are basically just things that are compatible with the IDE. Again, that's integrated development environment, but which the Scratch editor would be an IDE in this case. So things that are compatible with it, but are actually natively added to it. So for example, the motion category is natively added to Scratch, so it's an internal library, or the sounds category is already there, so it's an internal library. But these would be external libraries. They're not there by default, but you can add them. And so there's 9 here. And so some of these are kind of specialized. Some of these are more general. You see the second one here on the left in the top row. That's pen. That's by far the most common, by far the most popular. You know, translate is a close second, I'd say. But anyways, I'm just going to go over all these and then specifically focus on the pen as well, since that's really important. And so I'll just start with music. We'll just go left to right, top down. Um, Music, basically, that's where you can plug in and connect instruments to your computer, thus to your Scratch. The Scratch can read input from them and translate it to your project. So you could have something like Guitar Hero, if you know that what that is. You can make a little bit of a replica of that, or you could do something like you press some notes on a piano and then there's notes on screen. You got to match the ones you're pressing physically with ones that are popping up on screen, something like that. The pen tool is where you can literally have functions that'll draw any size, color, shape, format you want on your project. And I'll go into the pen, of course. We'll make a little bit of a demonstration project with that. That'll be pretty cool to see. We also have video sensing over here, which is sensing motion with a webcam or camera that's plugged into your computer. So you can actually use values in the sensing category with this that will actually recognize input from the camera, such as brightness and distance and things like that. And then based on that, you can make things happen in your project. Text to speech is pretty interesting. It's collaboration with AWS or Amazon Web Servers. Of course, it requires internet. That's what these 3 little bars mean. It's the Wi-Fi logo. Um, Basically, what this is you can actually have input in the form of text, and you'll get output in the form of speech. Familiar with the recent quote AI or artificial intelligence that Amazon is doing called Alexa, and they have this like the Amazon Echo and Echo Dot and all this, and it's basically speakers where you tell it stuff, and Alexa will return certain input as output and speech, except for like answer questions and stuff. That's basically what this is, except for it's just text. So you're giving it text, and it'll just return it in speech. So this is good for accessibility options. Basically the opposite of closed captions. If you've ever seen a movie and then you see like little captions, so you can see what's happening even though you can't hear it. It's kind of like the opposite of that. You can't see what's happening, but you can hear it. That type of thing. So translate. What this does is you can actually translate your text. So again, this is a text-based input, but it'll actually output the same text but in a different language, but still in the form of text. But that's very cool, and it's actually very practical for a lot of projects that are basically dealing with more than one language. If you want to make a translator in Scratch, you can very well do so with this translate library, which is pretty cool. It's a collaboration with Google. Of course, Google has translate.google.com, which is basically a subdomain of theirs, which can translate in a very large amount of languages fairly accurately, and there's like verification stuff. It's a very powerful engine that they have. Basically, Makey Makey is something that it's a kit from an independent company. Basically, it's kind of like something to teach electronics for kids. They've got like circuits, and it'll come with a bunch of alligator clips and USB, and you can basically just plug it into your computer and can make like really cool projects. These are like physical projects. I've seen things where they'll have like a mat on the stairs, and like if you step on different mats on the stairs, they'll like play different piano notes. So you can turn the stairs into a piano. So things like that. You can do things like that. And it'll just basically be this little motherboard here, and you can make these little up, down, left, right arrows, and these buttons do something in your project. You can kind of connect all that. And basically code what this does. Great for learning electronics. Microbit. Not too sure what microbit does. I assume it's something like Arduino and Redboard or SparkFun if you're familiar with those. It looks like that type of thing. Again, saying a little bit more intermediate way to teach kids about electrical engineering is pretty cool. Lego Mindstorms. EV3 is basically a model of Lego Mindstorms, which, oh yeah, I forgot to go over the microbit requires both Bluetooth and internet. This little Bluetooth somewhere here, going back to Lego Mindstorms. Um, Collaboration with Lego. Basically, Lego had this thing, which is like the building blocks company. They kind of had a something where it's like robotics, implementing robotics into Lego. Something like a little bit of a step up from Lego, where you can program this like little electronic motherboard and it connects to like motors and things like that. You can do some cool stuff there. Lego Boost. It's kind of like Mindstorms, like it's a little bit different. I've heard it's a newer one. It also requires Bluetooth and Wi-Fi, or Bluetooth and internet. Sorry, just like this other one. Uh, Lego Education We Do 2.0 is pretty similar to Boost. It's also a little bit newer. It has motors and sensors, so you can go ahead and use the input and output of in your project. Of course, Bluetooth and internet as well. Again, collaboration with Lego. This was collaboration with Vernier. It's the Go Direct Force and Acceleration. It's basically something to teach kids about like physics and things like that. It can sense, push, pull, motion, and spin, and based on the input, your project can provide output. It's really great for learning physics and things like that. So again, requires Bluetooth and internet. I'm just going to go ahead and click on pins since that's what we're going to focus on. Again, this is by far the most used. As you'll see, a little new category will come up. So we have our internal libraries up here, the ones with the colored dots. And we'll have our external libraries after my block, starting after there. So what the pin does, I'm just going to go over a brief example. I'm going to get rid of our cat here. I'm just going to go over a brief example, do some pretty crazy and cool things with the pin here soon. I'll just go ahead and go erase. All erases everything that the pin has. Again, the pin is a public. It's a public. These are public functions, so you can't have like pins that are specific to sprites or specific to your stage. It's like all public throughout your project. So stamp, pin down, pin up. I'll just go over what these are. First, I'm going to set our pen color to green. I'm going to go ahead and pin down. And basically, now our pen is touching. So anywhere our pen goes, basically it will go ahead and print until our pen goes up. All stamp does is just makes the pen go down and go up immediately. So your pen's always there, but if it's going down, then it's printing whatever its color, size, and all that is set to, or it's just kind of there and not really doing anything, but it still exists. So you can do some pretty cool things with this. So let's see. Oh, this is the stage, right? I'm just going to get some bananas here. Why not? Just to test something. Okay, it's all the same functions for sprites and stages. I had to verify, but I didn't think it would be anything different. But of course, they do change a lot of stuff with pen. It's something they've been updating pretty frequently. So this might not be the exact same screen you have whenever you're working with your pen tool, especially if you're watching this much later for the course. But it should be the similar concepts of these actually. I had this concept of the pen for like over 6 years now. So actually, if I'll just go ahead and look at our parameters for our change and set. You're going to be dealing with these a lot. We have saturation, brightness, and transparency, and we have those for set and change. It's kind of like how whenever we're doing set and change for variables, it's the exact same thing. Changes by a certain integer from the certain value, or from the current value, and then set, it just sets it to an entirely new value. And so we have color, we have saturation, we have brightness and transparency. The only different thing from what we'd be doing in our graphic editor, such as bitmap or vector, where we have color, saturation, and brightness. Only new thing is transparency, which is basically the same as opacity, if you're familiar with that. Basically shows that visibility is very similar to the ghost effect for the parameter we've worked with in looks, where we can set the ghost effect, for example, here. Very similar. Actually, it's basically the exact same thing. It's just a different word. I'm not sure why, but that's the way it is. We can also change and set pin size by default 1, but we can also change it. Pen color is default 278290. This color green, we can make whatever we want. Again, color saturation brightness. We can also drop her from our project. So if we want this color, we can always take that or any other colors we have visible on the screen. We can erase everything our pen has ever done. We can stamp. We can pen down and we can pin up. So that's pretty cool things we can do there. And that's pretty much as far as all I'll go with a pen for right now, but while we're at it, actually, come to think of it, I think I'll actually go over some ways we can move the pen, some ways we can actually use the pen within our project. So I'll just go ahead and do that real quickly. Alright, so I'm just going to go ahead and name my project first. I forgot to do that before I forget. So you can, of course, name this whatever you want if you're following along. I just want to go ahead and create a sprite real quick to demonstrate some of the movement and how we can actually use this pen in our project. I'm just going to go ahead and pick on the banana again, since I guess we just did that, right? So if we go bananas, we can see that it is, I'll just put them in X0, Y0, why not? Whenever we start, okay, like this. Alright, now he's an X0, Y0. If we look at our pen tool here, we can go ahead and go, oh, I don't know. Forever. Change X by 10, then stamp. I'll set the pen color actually first. I'll set the pen size to 10. Something like this. So what this did right here, whenever I ran the script right here, really it was running this script more than this script. It basically put us at X0, Y0. It went ahead and stamped and changed X by 10. So it just basically created a duplicate, a visual duplicate of the sprite, and changed X by 10. So this is actually different than creating a clone, because this is really only for visual display rather than actual functionality that you can actually affect each of these clones through code. But yeah. Now, actually, it doesn't reset after each time you click the green flag, which is pretty cool. Of course, you can just go erase all. And now our original is, well, our original is like wherever we last had it. So that's just an interesting thing there. But if we actually stop this, erase, something like that. Well, you can do some pretty interesting things playing around with this. I'm actually going to set erase all every time we click the green flag, so that way it restarts every time, just so we don't get like a million bananas flooding our screen. But that's what stamp does. That's pretty much, well, that's what stamp and erase all does. Let's talk about these two right here that I pulled out. I'll just make a separate little thing for this. Rather than having stamp, I'm just going to switch out our stamp function for pin down. So what this does is it actually changes our X value by 10 and holds the pen down. Now, the specifications of the pen are based on color, of course, also saturation, brightness, and transparency, and of course our colors right here, and also our size is the other one. So there's really 5 total. So that's color, saturation, brightness, transparency, and size. Of course, really we're just messing with this color and size here and leaving everything else to be the default values. And of course, change and set do work exactly like other change and set functions. We already kind of talked about that. So it's really just working about actually applying these, which is pretty cool. So we're actually erasing every time, and we're pretty much just drawing, which is pretty cool. Now, let's say we actually got rid of this entire costume. Would it still work? Well, the answer is yes. It would really work as a paintbrush more so, but it actually would, and it's being a little bit weird, it looks like. Oh, I think it's because I'm starting it too soon without actually giving it time to, yeah. Also, I'll give it time to clear. I'll do a wait 1 second before getting into our forever loop here. Oh, that's pretty cool. It's being a little bit weird. What if we did this? Forever. Set X. To mouse X. Forever set Y. To mouse Y. And I also want to go ahead and go forever. Pen down. Let's try this. So what this does is now we just have a paintbrush basically that's following our mouse, which is very cool, and we can change pretty much whatever we want about this project. We actually get this to work with that art project we did. We could just use the pen instead of actual sprites. Creating clones is just actually way more efficient. However, what the pen is really useful for is things like render machines, advanced art, doing 3D visualizations, all sorts of good stuff like that. So there are some weird limitations to the pen. There's always like some things. Oh, also another thing, you might be wondering why I can't paint into this little area right here. That's because our bananas right here is actually not centered. too well. So it's actually setting its X and Y to our mouse, and the center is actually somewhere more to the bottom and right. And this is actually outside of the sprite that's called bananas. Of course, there's actually no art there other than the brush. There's no actual art within the costumes. We deleted it all. But there's actually it's actually outside of the sprite, and therefore we cannot use the pin. And although the pin is public, some of its effects are sprite specific, such as drawing like this. So that's just another good thing to know. So you really can't do much with outside of that uh, 480 by 360, which are the dimensions. It's 360 tall and 480 wide for a screen. Can't really do much outside of that 480 by 360 dimensions for your sprite. So like if you go into your editor here, this is actually, we zoom out all the way, it's 480 by 360, and if you go outside of that, which in this case this is outside, then you're not going to be able to use it, but basically filled in all the visible spot here. Uh, and of course what you can't see is also drawing outside of the screen here, because the sprite is going off screen a little bit there. But anyways, it's pretty much a really simple example of the pin. Let's make it actually do something, like animate something, just so we can call it an actual project, if you will. Oh, I don't know. You know what? Since we're about to do that in the next lecture, I'll just go ahead and go to my project page. Move around your mouse and have some fun with it. Alright, one more thing. If you look at this area right here, this is where all the external libraries used in the project can be featured so that people viewing it or using it can know. So as you can see, since we're using the pin is featured right here. So this project will be shared in with everything else in our studio. So of course you can find it there. But thanks anyways for watching. And I really hope that you guys learned something, and I look forward to actually really using this in greater detail in the following lecture, in which we'll have a project where we make a render machine. So thank you so much for watching again, and I'll see you there.